Hello everyone, we're from team Astucieux, and today we're going to present the energy demand forecasting model for the lab 2. So the objective of this lab is to forecast the energy demand with a lead time of 5 hours for the power company's planning purposes. If we see the dataset of PGM load only.csv that consists of 2 columns, the first column consists of date in hour, and the second column is power consumption in megawatt. Then in the statistics and data normalization, we use this equation to normalize the data, and we use the mean and standard deviation to search the normalize.
And now we discuss about the feature and difference network. In this model, we use 28 inputs, consists of 23 hours difference and 6 hours of mean, standard deviation, maximum, minimum, and skewness. And our architecture of this model, we do some experiments with the number of layers and its neuron on the layer. We also do some regularization on this model, such as with decay, dropout probability, and early stopping. And we use also 2 solver types in this model, such as ADAM and SGD.
So after several trials and errors, we finally have our final architecture and use this model to forecast the data. We have 4 layers in a factor of 2/3 and weight decay of 10 in the power -6. And we have 10,000 iteration with the regularization type of L2. And for the NN size, we use 512. And for the solver, we use ADAM because SGD is actually better and faster for the larger dataset, but it causes inaccuracy. That's why we use it. And next, this is the results that we get. We have already beaten the persistent RMSE with a lot of margin. And as you can see, the persistence to beat is 0.11, and we have made the task loss become like 0.003, so it is much better. And there's no gap between the training and the task loss, of course.
Okay, as we can see, the training show good fit, and it's mean a strong correlation. And the right graph, the scatter plot actual versus training seen a straight line, and look minimum difference between actual and training. Also the test prediction. Actually, this is show the same result with training. And lastly, this is our lag graph. As we can see, that peak is approach 0.
For the conclusion, there are a list of things that can be done to possibly improve this forecast. Obviously, we could further reduce the test loss for this forecast and try for a deeper model with more layers. We could also use another solver type and add dropout to the network and add more features. So through this lab, we learn and understand the forecast pipeline and the model configurations. We could apply and do experiments with variant configurations, such as reduce the gap between the training loss and test loss, also the lag peak. And also, we could prevent overtraining the model. We learned that larger NN sizes take a long time to proceed, but decrease the test loss. And for the technical issues, in the weekend, the after cafe often being overloaded, so we wait for so long to train our model.
Thank you, guys.
Thank you.
Thank you.
Thank you so much.
Arigato.